One of the most exciting advances in technology for machine vision is the use of deep learning. And deep learning has really matured in being an enabler for solving complex machine vision applications which other conventional rule-based technologies were unable to solve to the accuracy required. But one of the key requirements or ingredients of a deep learning algorithm is data, and lots of data. So how do you actually overcome one of these challenges when you don't have enough data? Hi, my name is Raghava Kashyapa, and in this video we're going to exactly cover this. So what is the difference between deep learning and some of the other conventional machine learning techniques that were in use? Well, the key difference really was when it came to the number of images, machine learning algorithms sort of saturated or plateaued in terms of accuracy that you could generate, even though you sort of fed it or trained it with more data. Deep learning, on the other hand, had a very linear approach in terms of accuracy increase. So the more data you gave it, it was data hungry, and it could actually respond to the data training data that you would feed it with. So in other words, you could get higher accuracy by training it with more data. So the operative word for deep learning algorithms is data, and there's a number of research that is going in to see how we can make this more efficient, data efficient. So when it comes to machine vision, especially in industrial applications, you might be able to find a lot of data because production lines are pretty fast, they're automated. So if you had a fairly robust camera that's trained and looking at your products in manufacturing, you will be able to get a repeated set of images that you can then use for training data. However, it's not just the quantity, but also the quality of the data that is important. What do I mean by quality? The quality is not about how clear the image is, but how representative or how diverse the actual image data set is. So in other words, if you're looking for defects in a particular product, have you got enough images of defective parts, not just good parts? So in a production line environment, you may actually end up producing 99% of good parts, but only 1% of bad parts. And 99% of your data thus is going to be all of good parts. Now that may not be sufficiently balanced to give you that kind of accuracy in identifying the defects. So how do you overcome this particular challenge, the data problem that you have in machine vision, especially in industry? So there are a couple of different ways. Now, one, the very rudimentary level, when you train deep learning algorithms, you're presented with a pre-processing option called data augmentation. So you can use linear geometry or a simple, computer vision techniques to be able to take the limited number of features of the images that are presented and then recreate hundreds or even thousands of different examples from the same image synthetically using data augmentation. Data augmentation is nothing but using some simple operations like shear, skew, enlargement, brightness variations, etc. on the same image to then take the original input image and then recreate hundreds of thousands of additional images. That to a large extent may offer some relief into the data problem, but it's not really that accurate, or it's not that representative of real images that are going to be seen or real defects that are going to be seen. So the other techniques that you could use is what has recently been an advancement in deep learning is the use of GANS, or Generative Adversarial networks, are algorithms that are self-teaching and can be used by taking a few images and learning patterns from that and then creating additional images very similar to the ones that it has been used for training. But even with GANs, you do need a lot of sufficiently large data set to even come up with the algorithms. And not to mention that the techniques of using GANs is also quite complex, and so you need a sufficiently skilled engineering techniques to be able to make that reliable and make that more productive in your training pipelines. The third one, which is more recently that's come up, is the use of synthetic data modeling based on 3D modeling techniques. So there are a number of advanced companies that are offering this with using a variety of different 3D modeling techniques. So if you have a part and you want to really generate 2D data out of that, you model that part with the texture, with the right geometry, and then you create a very high fidelity 3D model. And using that, you can actually generate using different image processing and advanced graphics computation techniques to be able to generate 2D images out of it, even to the extent of very realistic defects that you can then superimpose those defects on those images and then create a number of different training samples that you can then incorporate into your training pipelines. So all these different techniques are in combination or independently can lead to some advancements and relief to the data requirements. Of course, nothing beats having sufficiently large data sets as realistic as possible captured at the source. But if you don't have that, you could probably consider one of those 3 different techniques that I talked about. But be prepared for some fantastic innovation that's going to be coming down the way. I predict that the use of either GANS or synthetic data is going to get very democratized. There'll be a number of data generation startups, innovation, and dollars that are going to be pouring into this space, and you'll see some exciting things coming down in the future. So I'm really sort of optimistic about deep learning and AI and how it can be used in machine vision. And we at Qualitas have been at the forefront, been working on this technology for the last 4 or 5 years, and I personally am